right, welcome everybody. Thank you for joining me today. So I actually know many of you, but just for giggles, how many of you are Android users? Okay. Oh, wow. How many of you then are Android developers or designers? Okay, cool. And how many of you have an iPhone? Just out of curiosity. Okay, cool. I used to, but now I don't raise my hand. Okay. So anyway, I'm Kristin Marsicano, and I'm here today to talk to you about the life and death of an Android activity. And before I dive into that, I want to start with a demo to motivate why you should care about this topic. So I'm going to demo you my life as an Android user. This is a picture of the Fox Theater in Atlanta, and I got a job moonlighting there being the door person. Not really, but I'll pretend. But I would like free tickets, so why not? So anyway, I made this ticker app because one of my jobs is to make sure we don't let too many people in, so we don't have the fire marshal show up. So anyway, it's a slow night, so I start my count. And I'm like, this is really boring, and I love this new multi-window feature that was introduced into Android, so I'm going to watch some video and use my ticker at the same time. And so I go into multi-window mode, and I select the video player, and oh, my count is gone. That stinks. And I don't really like the fact that I am not in portrait mode, so I'm going to increment my count and rotate, and what do you notice happened? The count's gone, 0. Okay, so basically there's a couple things going on here. As I increment my count, anytime I rotate the device or I move into or out of multi-window mode, my count is getting reset. Furthermore, you may or may not have noticed that I play my video, and anytime I'm clicking away, like I'm clicking on my ticker app, the video is pausing, right? So neither of these are very good user experiences. So today, I'm going to walk you through what's causing these sorts of problems so that if you're an Android developer, if you're not already aware of what's causing it, you can address them. And even if you're not an Android developer, so that you can start to understand some of the underlying ways that the operating system is working. So to that end, as we talk about what's causing these bugs we've seen today, the state loss and the weird play pause behavior in the video, we're going to be exploring something called the Android Activity Lifecycle. So let's step back for a minute just to unpack what the Android Activity Lifecycle is. Let's start really quickly with just what's an activity. So an activity, roughly speaking, represents a screen that the user is interacting with. All right, and so this is backed by a Java class, which is familiar probably to many of you DevOxians. And so you can see here, what's in this class right now doesn't actually matter, although it is important to note, because it's going to come up later through the examples, that we have this member variable with a count. And the count is initialized to 0, and this will be set to 0 anytime a new instance of this class is created. And then anytime the user is clicking on that button, it's going to increment that count. And then ultimately the UI label you see there that's showing the count is reflecting the contents of that count variable. And these activities usually are backed also by an XML file. And this XML file is called a resource file. This is a way for you to specify what widgets are going to be on the screen. And so in your Java code, you'll specify which XML file should be used, and you'll do things like hook up click listeners to buttons, so on and so forth. So that's an activity. And activities, as I said, are fundamental to your Android apps, really to the user. Your activity is the app, right? Because that's what they're seeing and interacting with. But you don't ever create instances of these activities yourself. Instead, what happens is there's something called the Activity Manager that lives outside of your application. It's in the operating system. And what will happen is that requests called intents are issued to this Activity Manager, and then the Activities Manager's job is to create instances of that activity and do something with them. So an example here might be that the user clicks on an icon on the launch screen, which issues an intent to the Activity Manager to start the ticker activity. So the Activity Manager is kind of like the router, right? It's going to figure out which class it should create an instance of. It's going to spin up a process for your app. By default, every app is going to get one process. It's going to create an instance of the ticker activity and put it inside of that process. And then it's going to move the ticker activity to the foreground, so it's what the user sees and it's what they're interacting with. So here's a view of our Android operating system. And it's really just meant to show, any given time, there's a whole bunch of different app processes running on your device. And so when the intent was issued to launch ticker activity, the operating system created a process for my terrific ticker app. It created an instance of my ticker activity and put it in that process, and it moved it into the foreground. And one really important thing to remember about Android activities, and it's going to come up again throughout the talk, is that only one activity can be the foreground activity across the whole system. The foreground activity is the one it's visible to the user, but more importantly, it is the one that they are interacting with. It's the one actively accepting the user input. So now we talked about what an activity is, what the heck is the activity lifecycle, all right? And so really, I think of the activity lifecycle as three main parts. It's a set of states that an activity can be in, and we'll go through these in more detail in a minute. It's a set of rules about how and when the state will change. And then it's a set of callback methods, I forgot I had my clicker, callback methods that will be called to notify the activity that is moving between states. Okay, so with these states, there were 4 of them, like I promised you we'd go in detail. There's really 3 main things to care about. Number 1 is the instance of the activity alive in memory? Number 2 is the activity's view visible to the user? And number 3 is the activity in the foreground? Is it like the one shining star that the user is currently interacting with? So we have a non-existent state, which represents the scenario, for instance, when the activity hasn't been launched yet. It's not in memory, it's not visible to the user, and it's certainly not in the foreground. Next is stopped. So stopped represents the state where now there is an instance of that activity object in memory, but the view is not currently visible to the user, and it's certainly not in the foreground. Paused represents a state where now we have an instance in memory, the view is visible to the user, if only partially, but it's not actively in the foreground. So we might get into the scenario, for instance, when you launch the activity and it quickly moves through the pause state onto resumed. So resumed is that foreground state I was telling you about, and it means the instance is in memory, the activity's view is visible to the user, and more importantly, the activity is now in the foreground, and that represents that the user is interacting with it. So the activities and their states at runtime, as a developer, you don't control which state the activity is in, right? That is dictated by what the user is doing, and in part what's going on across the rest of the operating system. So our job as Android developers then is to understand what those lifecycle states and callback methods really represent with respect to what's going on with the user and or the operating system, and then to structure your code within those accordingly to meet your app requirements. So I think the lifecycle activity, in my experience, has been best understood through example. So we're going to take a journey into the wild in the shoes of an activity instance. And I'm going to walk you through 5 scenarios that sort of demonstrate when these callbacks are called in relation to what is going on. So the first simple example, I like to call it like the build-up scenario. We're launching the ticker activity, so the user presses the icon, and the ticker activity is launched and displayed. This slide, I just want to take a moment to step back and tell you what it represents, because you're going to see it over and over. So in the left-hand side, there's that box called Android OS. There I'm going to show you what's going on with the ticker app process and what activities are living in there. And then on your right, I'm going to show you what the user is seeing on their device. Okay, and across the top, I'm going to walk you through which state the activity is in. Okay, so the user presses the icon, and we're currently in the non-existent state. And like I said, an intent is issued to the activity manager, which will spin up a process and create an instance of ticker activity, right? Our count is 0. And so we're in the non-existent state. OnCreate is called, which moves the activity into the stop state. Then OnStart is called immediately after that and moves us into the pause state. And immediately after that, OnResume is called, and it moves our activity into the resumed state. So now we're in the resumed state. Our app is visible to the user, and they can start clicking that increment count button. So now and resumed, right, that represents that this is the foreground activity, the one across the whole system. All right, So now let's talk about tearing down the activity. When the user presses back on Android, since you all are Android users, you know, but maybe if you're watching at home and you're not, right, there's this back button. And when the user presses back, they're telling the operating system that they are done with this activity. They don't need it anymore. Okay, so to that end, the operating system completely destroys the activity instance, as you're about to see. So let's say the user presses the increment count button to increment the count to 1. Then they press back. They're in the resume state, but automatically the operating system is going to start running it back down the life cycle. It'll call on pause, and then immediately call on stop to move it to the stop state. And then it's going to call on destroy before finally destroying the activity. Okay, so now the activity instance is completely gone. We're in the non-existent state. And I want to pose a challenge to you all. So the user presses the icon to launch the app again. What are they going to see? Is the number of clicks 0 or 1? Who thinks 0? Raise your hand. Who thinks 1? What? I'll guess 1. Okay, so the answer is 0. And it all boils back down to the fact that the activity instance, right, was completely destroyed. So it was recreated from scratch and run through this build-up cycle. And if you remember, our ticker activity, anytime a new instance was created, it was initializing that count to 0. Okay, good job, you all. So now let's talk about another scenario, pressing home. So on Android, there's also a home button. And pressing home is different than back in that the user is now saying, all right, I'm going away from this task for now, from this activity, but I might want to come back. And to that end, the Android operating system is not going to destroy the activity. So let's see what it does do. All right, so we're going to increment our count twice. We're going to press home, and we'll be on the home screen. All right, so we start out, our ticker activity is in the resume state. It's in the foreground. We've incremented our count to 2, and the user presses home. It moves them back through on pause to the pause state, back to on stopped, and now the user sees their home screen, their launcher, and the activity hangs out in this stop state. Okay, so now, let's say the user presses the icon again to open the app. What do you think they're going to see? 0 or 2? You can just hold up your hand with the number. All right, yeah, it's like peace, right? Okay, so the answer is 2. And again, it all boils down to, in this case, the activity instance was never destroyed. So it's not like recreating the instance from scratch and overwriting the mcount. Our state that was stashed in the activity object is still hanging around in memory. Okay, answer is 2. All right, so let's talk. We've got 2 more to go. Hang in there with me. So we're going to talk about fully occluding the view of the ticker activity. So let's pretend that our app has 2 screens now. So I press the icon to open my ticker, and I increment the count, and then I want to save the count. I'm going to save it to a file or to the network or whatever, it doesn't matter. But this will launch another screen, and I can enter a file name and then click Save. So here's where we're at. This is the state we're at. Our ticker activity is in the resume state. Now I click Save Count, which is going to issue another intent, and the operating system is going to create and spin up the save activity. I'm going to laser focus on ticker activity, so we're not going to mess with the business of what's going on with save activity, but ultimately it's there. So now the question is, what's going on with ticker activity, right? Because it's no longer visible to the user. So it moves from resumed through on pause to become paused, and then immediately through on stop to become stopped. And if you remember, if you think back to those 3 dimensions that I talked about that, that the states represent, right? Is it in memory, is it visible, and is it in the foreground? This starts to make sense because the ticker activity, it's stopped, which stop state means it's in memory, but it's not visible, right? And it's certainly not in the foreground. Okay, so the user is going to press back now on save activity, and save activity will go through its own life cycle and go away. And then the question is, what will happen to ticker activity? And it's going to spin back up from where it was to the resumed state, right? And so it moves through on start because it was stopped. So it moved from on stop through on resume to the resumed state. So you can see now that the life cycle isn't such that it always goes, all the way torn down, all the way built back up. It can sort of ebb and flow between these states, but it's always going to go, one by one through each of them. All right, so last example here before we move on. So launching a transparent activity. So here is a scenario where we're going to partially occlude the view of our activity. Another example of this might be, for instance, if you had like a dialogue-themed activity that appeared. So we're going to have a save count button, which I click. And now, I'm not a UX designer, so please don't fault me for this, okay? So I, for some reason, thought it'd be good to, have some context about what's going on, but probably the execution of this is not great. But, so you'll see I've got my save activity on top, but you can still see the UI for the ticker activity behind it. So start to think to yourself about the states we've talked about, what state ticker activity might be in, right? So if it's partially visible, but it's not in the foreground, what state is that? You don't have to answer. You can just think. Okay, so we were in the resume state. We click Save Count to launch our semi-transparent save activity, and it's going to move our ticker activity to the paused state, right, through on pause, because paused represents, like I said, the instance is in memory, and the view is visible or partially visible, but it's not in the foreground. All right, so our ticker activity will hang around in this pause state while our save activity is in the foreground. So when we click back off of our save activity gets destroyed, and the ticker activity is going to move back to the resume state. So you can see now it only had one hop to go, right? One callback till it made it back to the resumed state. Okay, so that's a walk in the shoes of an activity for a few common examples. So I want to step back and summarize for a minute, because I think of this activity life cycle in sort of three main subcycles when I start to reason about how to structure my Android code within these callbacks. So one is this notion of the entire lifetime of the activity, or the instance lifetime. Is there an instance of the activity in memory? And basically the way I think about it is that anytime after onCreate is called, I'm in this instance lifetime. There's an instance of my activity in memory. And then when onDestroy is called, I know I'm moving out of that lifetime. Then there's this visible lifetime, which represents when your activity's view is visible to the user. And so once onStart is called, I know that notifies to me that, hey, the user can now see my UI, see my activity, if only partially. And when onStop is called, I know my activity is moving out of view. And then finally is this foreground lifetime. This is, again, like I said, when your activity is at the forefront. It's what the user is interacting with. It's accepting their input, so on and so forth. And so when onResume is called, that's notifying to me that my activity is moving into this foreground or resume state. And then when onPause is called, I'm moving back out of it. Okay, so let's revisit the demo for a minute, right? One of the problems we had, one of the bugs, which is actually a bug I see a lot, and which you may see as an Android user, is this notion of losing state, right? My ticker count was getting lost anytime I rotated, or anytime I went into or out of multi-window mode, which I guess if I'd only counted 3 people, I wouldn't care, but if I had not paid attention and I counted all day, I'd be pretty upset, right? So how do we fix this problem? Well, first, let's try to understand what's going on, all right? When I am here happily counting, and I rotate my device, what the Android operating system is doing to my activity is the following. It's calling onPause to move it to the pause state, calling onStop to move it to the stop state, and then calling onDestroy, making it non-existent. So it's actually completely wiping away my activity instance from memory, which is a problem for my app, as I've shown you, because now when the instance is gone, I've lost that information about the count that the user has incremented up. All right? So what happens, though, as the device rotates, is it now creates a brand new ticker activity instance. And as you saw before, it's going to initialize my count to 0. And it's going to run ticker activity, this new instance, all the way up to the resumed state. Okay. So what the heck is going on? Why is this happening? So this is a lot of times, I teach Android people, as someone pointed out. And a lot of times people are really questioning, like, what's going on? So first of all, rotating the device or moving into multi-window mode, that's what's called a runtime configuration change. So in Android, there's this notion of the configuration of your device, and there's lots of different factors that contribute to that, right? There's things that can't necessarily change at runtime, like screen density, but then there's lots of things that can change at runtime, like orientation from portrait to landscape, or locale and language, or night mode, or multi-window, etc. So when a runtime configuration changes, Android, as you saw, completely destroys and recreates the activity instance. All right, and so part of why this is happening is it's allowing the operating system to choose resources that best fit the configuration. In the simplest example, this might be, you might want to have one layout file, one XML layout file for portrait mode, and another for landscape mode, where you've like displayed buttons along the side maybe instead of underneath. Okay, so the operating system's completely destroying the activity and then reselecting resources like strings and images and layout files, etc., that best match the current configuration. Okay, so now we know what is happening and maybe a little insight into why. The question is then, what the heck do we do? Right? There must be some way to address this problem. And there's more than one way, but one really simple way when you're dealing with transient UI state, state that the user would expect to be around, like if then they're rotating the device, they don't want that state to be gone, is to use something called Unsaved instance state. So Unsaved instance state is another callback method, all right? And this will be called by the operating system before onStop, but ultimately the idea is this will be called to protect your activity from destruction such that it's going to save the state that the user might care about. So you can override Unsaved instance state, and it takes in something called a bundle, which is like a hash map, right? It's a set of key value pairs, and you can stash information into that bundle. So in this case, I am stashing my count with a label of ticker underscore count. Okay, so then on the flip side, how do we use that state to restore our activity? And if you'll notice, this onCreate method, right, which gets called on the activity instance as it's being spun up, is accepting a bundle as an input. And so the information that you had stashed in Unsaved instance state is going to magically appear in that bundle in onCreate after rotation or after your runtime configuration change, whatever it might be. So you can use that information, pull it out from this bundle, and do what you may with it, right? In our case, we're going to update the UI to reflect the count that the user had before they rotated or before they went into multi-window mode. Okay, so just a little bit of a conceptual walk of what's going on under the hood then. So here's a picture of my terrific ticker process with my ticker activity instance living in it, and I'm calling it instance A. And the count is currently 3. So the user rotates the device, Unsaved instance state is called, which stashes something called an activity record somewhere in the operating system. The point is that what really matters is not where it's stashed, but it's more important the fact that this is not tied to your activity's lifecycle. This is going to persist past your activity being destroyed. So the record will get stashed with whatever information you put in the bundle will go along with it, and your activity gets destroyed. So now, as part of this rotation, the operating system will recreate a new instance of the activity, and it's going to pass along through onCreate that information that you had stashed in the bundle, right? So then you can use that to recreate the instance A. So this is actually a fully new instance of a ticker activity, but to your user, it's transparent that it was ever actually destroyed and recreated. Okay, and then the record will get cleared, and we move on. So key point here is to use save instance state to stash transient state across configuration changes. Okay. So one thing that I hear people say, and this is a very slippery slope, is like, all right, well, there's these runtime configurations, and I saw in the documentation or on Stack Overflow that I can avoid these. Like I can lock my app into portrait mode. I can tell it that it can't go into multi-window mode, etc. I'm going to tell you another story now about why it's not going to solve all problems by doing that, by eliminating configuration changes entirely. And this is a cautionary tale. I like going home, but this one is a cautionary tale. Okay, so user is on my ticker activity, and they press home. Okay, so we move through on pause, through on stop to the stop state. Now I go play Pokemon Go. Okay, or whatever game or thing you want to do that's going to take up lots of memory. And all is fine and dandy until, all right, there's memory pressure. And the system is starting to say, well, wait a minute, I need to clean some things up, all right? your ticker activity is in the stop state. It's no longer visible to the user, so it is fair game for the operating system to just completely destroy your entire process. And when it destroys your process, it's going to destroy any activity instances or anything you had stored in there. All right, so your activity is going to jump from the stop state to the non-existent state. Okay, and by the way, onDestroy will not get called, but ultimately your activity is gone. All right, but so the message here is beware the Viking killer. All right, so even if you're locked in portrait mode and all of these things and you're handling configuration changes on your own, your activity can still get killed by the operating system. And so anything in your instance in memory is going to be wiped away. So you want to have some means to save that. And one way to save the transient UI state is to use this onsaved instance state. So again, onsaved instance state is going to work for configuration changes and also for this Viking killer process kill situation. Okay. All right. So we have now addressed the issue with losing state across rotation and now also in the process kill situation. Let's revisit for a moment the issue with the video. If you recall, whenever I played the video and then clicked back in multi-window mode to increment my ticker, it was pausing my video, which is kind of a frustrating experience. All right. So given everything that you know about the activity lifecycle at this point in time, let's look at multi-window mode. All right, so let's say that I have just clicked on increment count. Which state do you think that my ticker activity is in? I clicked on it, I'm interacting with it. It's in the resume state, right? It's in the foreground, it's in the resume state. So what about my video on the left? I've clicked on ticker. What state do you think the video player is in? Paused. Exactly, it's paused. So it's visible to the user, but it is not in the foreground. Remember, only one activity can be in the resume state at a time across the entire system. Okay? So the video on the left is paused. So probably what has happened, and I know what's happened because I hacked up the ExoPlayer demo code to make it happen, but I assumed when onPause is called on the activity, I'd want to pause the video, right? It makes perfect sense. But that doesn't actually make sense, right? What we really want to do when we're deciding about what to put in these lifecycle methods is to think about what those callbacks are signifying, like what it means is happening to the activity with respect to the user, and what our requirements are. So my requirements are I want the video to play whenever the player is visible, even if it's not in the resume state. And I want to pause the video automatically when the player is not visible, right? So then the question is, in which callback method would I want to, say, hey, start or unpause my video playback? If I want video to play, start automatically playing again anytime the activity is visible. On start. I heard you say. So on start, that's correct. Because remember, on start signifies to us that the video is becoming visible again. And when do we stop, or so when am I going to pause my playback if my requirement is I want video paused when the player is not visible? On stop, right? Because that's moving us out of the visible lifetime. Okay. So I had one more example that I'll go through really quick before we wrap up here to further give you an opportunity to reason about the activity lifecycle because you've invested so much time and energy walking in the activity's shoes with me today. So here's an example where I want to show a user their location on my own map. Now I borrowed this picture from the documentation, so these are obviously not my apps, right? But on the right, I want to show the user their location on this map. But I want to minimize the battery consumption, right? I want to be a good citizen. And so, but I want to maximize the precision when the user is actively interacting with my map. So questions start to come about when might I want to start sampling location? When might I want to upgrade the precision, like maybe use a higher cost radio? When do I want to downgrade that, et cetera? So I want to start sampling for location in sort of a lo-fi manager when the activity becomes visible. Which callback would I do that in? You all didn't know you were going to be quizzed. on start, right? Because on start moves me into the pause state. When I'm in the pause state, I am visible. Okay, so when am I going to increase? I want to increase the accuracy of my location sampling when my activity is in the foreground, when the user is interacting with my map. When would I want to do that increase in either sampling rate or use some other radio on resume? Okay. When would I want to decrease the accuracy when my application is not in the foreground? So the user can see it, so I still want to sample, but maybe I'll slow down the sampling or I'll use a less battery costly means to get the location. When would I do that work? On pause, right? Because that's moving me into the pause state where I'm visible but not in the foreground. And then finally, when will I want to stop sampling when my map application is no longer visible, so I'm not like eating up battery power when my application is in the stop state, like maybe the user has pressed home. I kind of gave away the answer to that one on stop. Okay, so the thing is that one of the points I want to make is that at least when I started learning Android, I wanted a formula, and I still do, to be honest, for most things, right? I want someone to say to me or be able to read a book and it says, yes, in this scenario, you put the code there, and in that scenario, you do X, Y, and Z. But the fact of the matter, it's not really that cut and dry, okay? There are some things that I've learned over the years that have proved very helpful when it comes to lifecycle, and one is the notion of lifecycle pairs. And so the idea is that if you are going to, for instance, register a listener or something, set something up, in a callback when you're building up, you want to tear down or unregister that listener in the corresponding tear down method. So lifecycle pairs would be on create and on destroy, right? On start and on stop, and then on resume and on pause. So if I set up a listener in on start, I want to unregister it in on stop perhaps. Okay, and there are other various rules of thumb that you'll learn as you make more and more Android apps. In on create, you may want to be checking the saved instance state bundle. You will be setting up which layout file your activity is going to be associated with. You may be setting listeners on buttons, etc. On start and on stop is usually where that represents, remember, the visible lifetime of the activity. So that's where you may want to be considering starting animations or setting anything related to the UI that is using CPU, and on stop you would want to stop that stuff since the user won't see it. Okay, and on destroy is your last callback where you can tear things down, but like I said, on destroy is not necessarily guaranteed to be called, but if that is the case, then the process has been destroyed, so you're usually in good shape. Okay, but in reality, what you put in those lifecycle methods really depends. And like I said before, it's a marriage of what the requirements for your user interface are, married up with what the lifecycle callbacks actually mean with respect to what the user can see and do or is seeing and doing, and also what's going on in the rest of the operating system. Okay, so now we have unlocked, this is an old GIF, but you have unlocked the achievement of understanding the activity lifecycle, or at least you've gotten a quick tour through it. Okay, so if you enjoyed this talk or you hated it, let me know. You can reach me on Twitter or my GitHub, pretty much anywhere on the internet. I'm Kristin Mars. Or you can check out bignerdranch.com. Big Nerd Ranch is where I work. And as you can see here, that's the old version, but I also co-wrote an Android programming book, which is great for beginners. I have a copy here to give away if anybody's interested. So you can check out that. We do app development, we teach week-long courses, and as you saw, we write books. If you're interested in any of our Big Nerd Ranch boot camps, I have been given a code that anyone can use to get 10% off any class. We have iOS, Android, web, front-end and back-end, and then also design classes. Okay? So that's it.